So far, we have learned together 3 different guidelines in this section, or 3 different theorems. The first theorem said, if you have a base with an exponent, usually the u should be the base. The second guideline said, if you have a letter e in the problem, the power of the letter e should be the u of the problem. And then finally, if you have a fraction, the denominator should be the u of the problem. Now, sometimes it's easy to get confused. This problem looks like a fraction, so it sounds like we should be using guideline number 3. But actually, it turns out that this does not work out with guideline number 3. It actually needs guideline number 1. There's a base right here in this problem with an exponent. So that's the guideline I should be using. So if you're confused, if you don't know which guideline to use, always start in the order that we learned them in. We first learned about the base power guideline before we learned about the fraction guideline. So try that first, and if it doesn't work, try the fraction guideline. So in this problem, I'm gonna make the u be the base, which is x squared plus 10. So then what would the derivative look like? What would the du be? The derivative of x squared plus 10 is going to be 2x dx. And that's my table that I need to do the problem. Keep in mind, in this problem, the 2 is right there, but it's missing from the numerator. So here's what we're going to do next. We're going to rewrite the problem. We're going to put the x and the dx together next to one another. We're going to put the x squared plus 10 to the power 4 underneath. And the 2 that's missing, we're going to go ahead and write it down. That's the 2 that we need, so we're going to put it there. But this changes the whole balance of the problem. So what we do next is divide by the 2 on the outside. That way things stays balanced. Now from this point on, the 1/2 on the outside is just going to go for the ride. And now we're going to ask ourselves, what do we replace the 2x dx with? What is that supposed to replace? And according to the table, whenever I see 2x and dx together in one single spot, I get to erase them and write in their place du. So I get to grab the whole thing and replace it with the variables du. Great, so then what? Now on the denominator, I have x squared plus 10. That itself gets replaced with the variable u, because in my table, I said anytime I see x squared plus 10, that gets replaced with the letter u. So that's what I'm doing. And the exponent 4 is going to stay. Now this fraction that we have here is different than the fraction in the previous problem. How is it different? It's different because the denominator in this problem has an exponent of 4, whereas the previous problems that we've done together, like for example this fraction, the exponent there was a 1. And that makes a huge difference. If the power is 1, we keep the u on the denominator. If the power is not 1, if it's like a 4 like it is here, then what we have to do is we have to bring the variable to the numerator by giving it a negative exponent. So I'm gonna basically bring my 4 from the denominator to the numerator, but give it a negative exponent. And now the 1/2 stays there in front, and the u gets a new exponent. It's no longer the ln rule. Now it's the rule where you add 1 to the exponent and divide by the same thing. So add 1 to the -4, you get -3, and divide by the same thing plus c. So basically, we took the whole integral and we replaced it with all those things. Okay, so that was that step. And finally, replace the u back with the original numbers. When we do this, we're going to multiply the 2 and the -3 together. That will be -6. And we're going to replace the u back with the original stuff. What was u supposed to be in this problem? Just go ahead and bring it back to life. The u was supposed to replace x squared plus 10. And that stuff has power -3 plus c. So this is one way to leave the answer. Another way to leave the answer is, if you like, you can write it like this. 1 with the negative in front, the 6 on the bottom, and then the x squared plus 10 to the exponent 3 plus c. So basically, you're going to notice, hey, I have a negative exponent. I don't like that. Let me put it on the denominator with a positive exponent. Both of those final answers are acceptable. I don't care which one you pick, and neither should you. They're both the same.